What is the OSI model? The Open Systems Interconnection, or the OSI model, describes 7 layers that the computer system uses to communicate over a network. So yeah, it was the first standard model for network communications adopted by all major computer and telecommunications company in the early 80s. It's about 43 years old. So yes, which is 7 layers. Let's just go through the layers, which is layer 7. The application layer is used by end user software, such as web browser and email clients. It provides protocols that allow software to send and receive information, present meaningful data to users. A few examples of application layer protocols are HTTP, for internet, file transfer protocol, which is for transferring files, I believe, over a system. File transfer protocol applies to just sharing files anywhere. It's a standard standard that enable transfer of files between computers over network. It was developed in the 70s AM. FTP works in the client-server architecture where a client computer connects to a server to transfer files. A server runs an FTP server software and the client runs an FTP client software. The client sends requests to the server to upload or download files, and the server responds by sending the request files for acknowledgement. It's pretty easy. FTP uses 2 channels to transfer files, a control channel and a data channel. The control channel is used for sending commands and response between the client and server, while the data channel is used for transferring the actual file. FTP uses TCP/IP protocol to establish a reliable and secure data transfer. FTP also supports different authentication methods such as username and password or public key authentication to ensure secure transfers. To ensure secure file transfer. However, due to the inherent lack of encryption, FTP has been gradually replaced by more secure file transfer such as SFTP, Secure File Transfer Protocol, and FTPS, which is FTP over SSL and LS, which now this is excuse me, leads me to more questions like, hey, what is S, which is secure? I know it has to do with internet, obviously. Which secure socket layer and transfer layer security are cryptographic protocols that are used to structure communications over a network. These protocols provide encryption and authentication mechanisms to ensure the confidentiality, integrity, and authenticity, the authenticity of data transfer between clients and servers. SSL was first introduced in the 80s. It was later replaced by TRL, which are a more secure and advanced version of SSL. TSL is now the industry standard protocol to ensure communications on the internet. So TSL works by establishing a secure session between a client and the server through a series of handshakes. During the handshake, the client and server agree on a shared encryption key and authenticate each other's identities using digital certificate. Once the handshake is complete, the session is encrypted and all data exchange between the client and server is secured. So this is the session layer, which is 5, right? Yeah. TLS supports different encryption algorithms and key lengths, which provide different levels of security. It also supports different versions of TLS. 0.1, 0.11, 0.12, 0.13. Latest versions. The latest version 1.3 provides enhanced security and performance. TLS is widely used to secure various types of network communication such as web browsing, email, instant messaging, and file transfer. It is also used to secure communications between servers in a data center or cloud center. Okay, so it's still used even though it was replaced. SSL. No, I mean TSL replaced SSL, which it's called transport layer security. And secure socket. Secure socket. Suck it to me. Alright, where was I? But yeah, file transfer protocol. And POP is internet post. Has to do with mail. It should have to do with email, probably. Post office is a standard internet protocol that is used to retrieve email. I know that. Because I know there's POP3, which there it goes. It's used to retrieve email messages for a mail server. It is one of the most widely used email retrieval protocols along IMAP, Internet Message Access Protocol. POP, dirty POP. No, you got that dirty POP. Yo, POP, you dirty. POP was first introduced in the 80s. Yo, all of this was introduced in the 80s and has since been updated several times to include additional features and security mechanisms. The current version of POP3, dirty POP3 works. The current, yeah, whatever, that's the current version. POP3 works by allowing email clients to connect to an email server and download email messages to the client's computer or device. It uses TCP/IP protocol to establish a reliable connection between the client and server. So all of these obviously application layers, they go up and down, because obviously they need the presentation for encryption and for it to decompress and to compress. Okay, but let me continue. When a client connects to a mail server using POP, I think I read this, but I'm not sure. The server sends a greeting message to the client, and the client sends a request to authenticate using a username and password. Once authenticated, the client can download the email messages from the server. POP3 only downloads the email messages to the client's devices and does not synchronize the email messages across multiple devices or clients. So pretty much it's just used to retrieve it. Yes. And the request is using username. So it sends them. I have to read this again. When a client connects to a mail server using POP3, the server sends a greeting message to the client. Okay. And the client sends a request to authenticate using username and password. Okay, POP3 also supports different authentication methods such as plain text authentication and encryption authentication using TLS, which which is transport layer security. Although POP is still widely used, it has some limitations compared to IMAP or IMAP, whatever they want to call it. For example, it does not support synchronization of email messages across multiple devices or email clients. This means that if a user reads an email message on one device, the message will still appear as unread. Okay, so that's where I was getting confused at. And it pretty much answered me. So that's why POP, the new POP sucks. So it's better to have a step POP, which is IMAP. Because iPop does not, if you read it on one device, it will not refresh it on every other device. It'll still look like it's a brand new email. Okay. Damn. And simple mail transfer. I'm assuming this is what sends. What you could send, what is used to send emails. Is used for sending, routing email messages between servers. It is an application layer protocol that is used to transfer email messages from a mail client to mail server or between mail servers. SMTP was first in the 80s, like all the rest, and has since become standard protocol for sending email. It works by allowing a mail client to send email messages to a mail server, which then forwards messages to the intended recipient mail server. Reptile, that's what I kept getting from it, like Mortal Kombat. SMTP uses a series of commands in response to transfer email messages. When a mail client sends an email to a mail server, it initiates an SMTP session by sending hello command, right? So it initiates a session by saying your hello. The server responds with a greeting message and a status code. The client then sends the series commands to provide the reptile's email address, subject, and message body. The server acknowledges each command with a status code, and if the message is accepted, it forwards the message to the reptile's mail server. SMTP also support different authentication methods, such as username and password for public authentication to ensure secure email transmission. SMTP is a reliable protocol for sending email messages, but has some limitation. For example, it does not support encryption of email messages, which means that email messages can be interpreted and read by third parties. To address this limitation, SMTP is often used in combination with other email protocols such as POP3 and IMAP, which is support encryption. I need to look up IMAP because it seems like IMAP does both sends and receives. IMAP, Internet Message Access Protocol, which is a standard internet protocol for use of accessing and managing email on a mail server. It is one of the most widely used email retrieval protocol, alongside POP. IMAP was introduced in the 80s, like all of them, and has been updated several times to include features and security mechanisms. Is IMAP 4, Internet Message Access Protocol 4. IMAP works by allowing email clients to connect to an email server and access email messages stored on the servers. Like POP, IMAP synchronizes, which is what I was talking about earlier, that it synchronizes messages across multiple devices and email clients. This means that if a user reads an email message on one device, the message will appear as read on all other. When a client connects a mail server using IMAP, the server sends a greeting message to the client, and the client sends a request of authentication, uses username and password. Once authenticated, the client can access the email messages stored on the server and perform various operations such as reading, deleting, and moving email messages. IMAP supports different authentication methods such as plain text authentication, encryption, authentication using TLS. Additionally, it supports different mailbox management such as creating and deleting mailboxes and searching for specific email. Okay, so when you're searching and you're deleting stuff, you're using. It didn't say nothing about pop using it because it can't even refresh. But IMAP is widely used to manage email messages across multiple devices and email clients. It is often used in combination with other email protocols such as SMPT, which is widely used to send. So no, IMAP is just to send. And the DNS, which is the domain naming service, which is, I believe, is when you go to like google.com, or it connects emails. I mean, not emails. It connects your internet, your IP, or an IP address to a name like Google.com's IP addresses. I'm not sure, but it connects that. So it's a hierarchical distributed naming system used to translate domain names into IP addresses and vice versa, which is kind of what I was saying. So it translates domain names to IP addresses and IP addresses to domain. It's a fun I don't think I need to read that part. DNS works by using a distributed database system that stores information about domain names and associated IP address. The database is distributed across a network of DNS servers, which each server contains information about a subset of domain names. So here goes to an example. When a user enters the domain name into a web browser or application, the application sends a request to a local DNS resolver to resolve the domain name into an IP address. The resolver sends a request to a root DNS server, which responds with the IP address to a top level domain, top level TLD, such as .com.org or .com.org. The resolver then sends a request to the TLS server, which responds with the IP address of the domain name. So yeah, so it seems like it just bounces around until it finds where this thing is being hosted, or where is the address. It's mailman. Okay. Sheesh. The presentation layer. The presentation layer prepares data for application layer. For the application layer. I fucked that up, I think. The presentation layer prepares the data for the application layer. It defines how two devices should encode, encrypt, and compress data so it is received correctly on the other end. The presentation layer takes any data transmitted by an application layer and prepares it for transmission over the session layer. So I mean, this is when it's going backwards. I guess when it's taking the data from the browser to the presentation, which just says the presentation layer takes any data transmitted by the application and prepares it for transmission over the session. So it re-encrypts it. So it encrypts it, it compresses it, and then sends it to the session, which the session just controls pretty much the flow, which the session layer creates communication channels called sessions between devices. It is responsible for opening sessions, ensuring they remain open and functional while data is being transferred, and closing them when communication ends. The session layer can also set endpoints during a data transfer. If the session is interrupted, devices can resume data transfer from that last endpoint checkpoint, not endpoint check. So it saves checkpoints as well, because if something gets lost, it'll kick it back off, and then you start from that same spot. The network layer. The network, which is IP, I believe. The network or communication between routers. The network layer has two main functions. One is breaking up segments into network packets and reassembling the packets on the receiving end. The other is routing packets by discovering the best path across a network. The network layer uses network addresses, typically Internet Protocol address, which is IP, to route packages to their destination. So it's responsible for sending pretty much packets and receiving packets. Yeah, it's pretty much breaking them up. When it's breaking up, but it's responsible for two functions. Like I said, breaking up the segments and then reassembling the packets on the receiving end. Okay, the data layer, which is the MAC address, or right here, or switches or hubs, which aren't really used. But the data link layer establishes and terminates a connection between two physical connected nodes on a network. It breaks up packets into frames and sends them from source to destination. This layer is composed of two parts. Logical link, which is the LLC, which is not like a business, which identifies the network protocols, performs error checking, and synchronizes frames, and media access control, which uses MAC addresses to connect devices and define permissions to transmit and receive data. So you got the logical link control, which identifies the network and protocols and performs error check-ins and synchronized frames. And then the media, which uses MAC addresses to connect devices and define permissions. And then lastly, the physical layer is responsible for the physical cable or wireless connection between network nodes. It defines the connector, the electrical cable or wireless technology connecting devices, and is responsible for transmission of raw data, which is simply a series of ones and zeros, while taking care of bitrate control. And here it compares. That was a lot of reading though. But yeah, this is actually a good link, I feel. But that was the OSI model. And if you go to imperva.com/learn/application security/OSI, you can take a look at it. So that was the OSI OSI layers. So thank you and goodbye. Oh, I'm here recording this thing.